Let's continue talking about the scope of identifiers, looking at more examples. There are some cases which are not straightforward to understand. Next example. For loops also declare local variables. Here, variable x of the for loop doesn't allow us to see the global variable as well when we're executing the loop. So we have a global variable x, we have a global variable y, they initialize to 1 and 0 respectively. Then we have a global variable z that stores the value of y, but after executing this for loop. This for loop is executed twice, once for x equal 1 and one for x equal 2. In each run of the loop, y accumulates the value of x. So in the first run, it gets value 1, and in the second, it gets value 1 plus 2, 3. So when we exit the for loop, the variable x disappears, y has the value 3, and this is the value we store in y. So we see exactly the same behavior for these variables in for loops as we have seen with local variables in methods, as we have seen with parameters in methods. Of course, we don't encourage you to follow this example, to use the same identifiers everywhere. We can nest even more. Here we see where we take this to the limit. We have a global variable x, we have a method with parameter x, and inside this method we have for loop with another variable x. So in this case we have three x's, the black, the red, and the green. So when we call f of x plus 2 in the last line, where x equals 1, so we call f of 3 in order to compute z. So we enter the method with x equal 3. Inside of the method, we declare the variable y, initialize it to 0, and then we enter the for loop. This for loop is executed twice, as in the example before. So we declare another variable, the green x now, that makes the red x and the black x invisible momentarily while we execute the for loop. Here we accumulate the values to y. Y at the end gets 3, and we return y plus x. But which is this x? It's not the one in the for loop, it's because we have exited the for loop. So we have the red one, 3 plus 3. This is what we return to z, which is added to x, but in this case it's the black x, so we return and we assign a 7 to z. So we don't encourage you to follow this example. It's just to show you how this nesting of environments makes such a program possible. Now, this seems easy to analyze. F is defined in the context where x equals 1. So this method always returns 1, independently of where it is called from. So x equals 1, and z is also assigned to 1. It is important to notice that f gets its definition in the place it is defined. If it is defined in a place where x equals 1, f is defined to always return 1. This example makes this point clear. We have two methods, f and g. G calls f, and it calls it in a context where x equals 0, whereas it was defined in a context where x equals 1. We just said that f always returns 1, independently of where it is called. In other words, variable x is bound to the value it has when the method is defined, x equals 1, not when it is called, x equals 0. This is called lexical scoping or static scoping, in contrast with dynamic scoping. Most of the programming languages today have static scoping. Some variants of Lisp and some shell script languages have dynamic scoping, but Java has static scoping. So once a method is defined, its meaning, its behavior, it's carved in stone. Remember, carved in stone. Once defined, its behavior remains the same, carved in stone. Now, if we remove the topmost declaration of x, x is not defined when f is declared. Therefore, this code segment would give an error at compile time. Not only variable names are bound to values, methods also have names, and there's a binding for that. But we'll talk more about it at some other moment. It is convenient and practical to reuse variable names, if we do it in a reasonable way. But it comes with a price. We have to understand which variable we are referring to if there are more with the same name. A variable can be temporarily not visible if there's another one with the same name. Local variables can be defined explicitly or implicitly as variables in loops or parameters in methods. It is important to remember that the method gets its definition in the environment it is declared, not in the one it is called. Remember, carved in stone once defined, carved in stone.